Hello class, I want to take you through a lesson titled A Little Bee Changes Everything. The last time I was in front of you, I believe we talked about this form, and we saw that when a was positive or greater than 0, it was up. A is less than 0, it was down. We also saw that a could make it skinnier or wider, okay, depending on how large or small a was. So then we looked at adding a little bit more. We figured the a out. We said, what if we just added c? Well, without the c, vertex of the function y equals ax squared. With no c, the vertex is 0, 0. We realized when we added c, the vertex was now at the point 0 up c. Now I need to show you what happens when we add the b. So we're now going to look at the complete formula with the quadratic term and the linear term. Now you can follow along in your book, and you'll see a lot of the same things that I'm going to talk about. So typically this graph would be centered on the origin. Without this term of 2x, it would be centered right here, and it would be having the steeper slope. But that's where it normally would be. But now when we find that we add this linear term, it moves the vertex, and it moves it slightly down along this linear path. And you'll see that change happen slowly and slowly as you add more and more. So here's 4x. If we were to add 2x, it'd be here. If we add 4x, it's down here. And then finally, way down here, if I get my 6x. So it's moving the vertex down and to the left. And so there is a pattern there that we can start to realize. So that pattern is described in your book. You'll see it again right here on page 557. There is a place where it describes this property in a box, but what you need to know is that the line of symmetry for any ax squared plus bx plus c quadratic, so a quadratic with a linear and a quadratic term, this line of symmetry will always happen at an x value that equals this ratio, the ratio of the opposite of b and 2 times a. The helpful hint there is that the vertex will then happen always at this location. So this part here with the f of the opposite of b over 2a can kind of be confusing. Let's look at an example on page 558 in your book. We have the quadratic equation. Again, there is an ax squared, so that's a quadratic term. There's also a linear term, this is the bx now. So we follow this rule that the line of symmetry happens at the opposite of b, so the -6 over 2 times a, so 2 times -3. And this would give us -6 over -6, which is, of course, 1. So that tells us that the line of symmetry for this graph happens when x equals 1. So a little line right there. Now, what does that mean for the vertex? The vertex means that this is the x value for the vertex. So the vertex happens on this line of symmetry. This is 1. And so this says find the function value at that 1. So find out what happens when the line of symmetry, which is the x value for our vertex, gets put in here. We get -3 times 1 plus 6 times 1 plus 5. Alright, so we have 11 minus 3, that gives us 8. And so the vertex for this happens when x is 1, which is on the line of symmetry, so I know it's right on here. when x is 1, I put it into my function and the value I get out is 8. So that's why the vertex is there at 1 and f of 1, which would be 8. So that gives us most of the picture. The rest of the picture is filled out by this -3. And that -3 tells us it goes down, but we need to fill it out, so we need to find some more values here. We need to determine what happens at other values nearby this line of symmetry. So we could stick with positive numbers to make it easy and just figure out 2 squared would be 4 times -3. And so this would be pretty easy to figure out. They cancel each other out. I get at x is 2, y equals 5. Okay, and so that made it go down 3, and that kind of makes sense with what a is. And we can just continue a little bit further. Okay, 3 squared is 9 times -3 plus 18, that would be 9. Sorry, -9, and -9 plus 5 would leave us at -4. So when x is 3, y is -4, and that just gives us a couple more points. 3, -4, and then when I plug in 2, I got out 5, so 2, 5. And you may say, well, that's only half the picture. Well, I can get the other half by using the idea that this is the line of symmetry. So I should be able to say, if there's a point right here, then over here, there would be another point just on the other side, and over here would be another point. So I'd use that line of symmetry to help me determine my new points, and now all of a sudden I've got a pretty good picture of a very steep, very difficult to draw parabola with its vertex at 1, 8 and its steepness and direction of -3. Your homework assignment is due Friday at the end of class. I realize you're learning this lesson online, so you may have questions, but I would hope that you'd talk to your classmates. You consult your book. You could re-watch the video. You'll also be able to find a link to the video. Simply check my wiki tonight for that link, and good luck.